Hello everybody and welcome once again to this series of laboratory measurement in public health engineering. In today's program, we will talk about hardness and its measurement in water. Hardness in water is caused due to presence of multivalent metallic cations. The most abundant present are calcium and magnesium. Hardness is of two types, temporary hardness and permanent hardness. Temporary hardness is caused due to carbonates of calcium and magnesium. It is also termed as carbonate hardness. It can be removed by simple processes like boiling. Permanent hardness is due to presence of sulfates and sometimes chlorides and nitrates of calcium and magnesium. It is also termed as non-carbonate hardness. Permanent hardness cannot be removed by processes of boiling. Hardness is measured in ppm on calcium carbonate scale. A concentration of 100 ppm is allowable for drinking water. We measure hardness by simple technique called volumetric method. It is known as EDTA titrimetric method for this case. We need simple glasswares like burette of 25 or 50 ml capacity with a burette stand, a measuring cylinder of 100 ml capacity, conical flask of 250 ml capacity, glass funnel, a pipette of 1 ml capacity and a dropper. The reagents required are sodium salt of EDTA, Arichrome black tea, hydroxylamine hydrochloride, ammonia buffer, magnesium chloride and 95% ethyl alcohol. We also need deionized water and to boil water we shall require a hot plate. Now first we have to prepare reagents of desired concentration. The EDTA standard solution is prepared by dissolving 4 gram of sodium salt of EDTA and 0.1 gram of magnesium chloride in 800 ml of water. To prepare Arichrome black tea indicator, you take 0.4 gram of Arichrome black tea powder and 4.5 gram of hydroxylamine hydrochloride in 100 ml of 95% ethanol. The ammonia buffer is readily available or it can be prepared by dissolving 16.9 gram of ammonium chloride in 143 ml concentrated ammonium hydroxide and then add 1.25 gram of magnesium salt of EDTA and dilute to 250 ml with distilled water. Dilute 10 ml of this solution to 100 ml with distilled water and this solution is stored for no longer than 1 month. First, we determine the total hardness. Fill the burette with the standard EDTA solution. And 5 to 6 drops of Erichrome black tea indicator. This is also called EBT indicator. Now the color changes to dark red. So we can start the titration. So note down the initial reading, record the value in Proforma. Now start titration. So the change of color to the blue is the end point of the reaction. Now note down the final reading. Record the value and find the volume consumed. Repeat the test till we get concordant values. The concordant reading is 1.6 ml. Now we shall determine permanent hardness. So take 100 ml sample . Take the sample in the beaker and put it on the hot plate. Now we will boil the sample. When it comes to the boiling temperature, we will boil the sample for 15 minutes. Now during the process of boiling, the temporary hardness will be removed, and when we repeat the experiment, then we will be able to determine permanent hardness. After 15 minutes, remove the sample and allow it to cool. During boiling of water, some volume is lost in evaporation. To make up for the same, we will add distilled water. Transfer it in conical flask. In the same manner, we will add 1 ml of ammonia buffer, and 5 to 6 drops of EBT indicator. Note down the initial reading. Titrate the sample till the blue color appears. Note down the final reading. Find the volume of EDTA used. Repeat the process till we get concordant value. The concordant reading is 0.7 ml. Total hardness on calcium carbonate scale is measured as ml of EDTA used for unboiled sample into 10 to power 3 divided by ml of sample, which in this case is found to be 16 mg per liter. A similar formula is used to calculate permanent hardness, but for the ml of EDTA used for boiled sample. And temporary hardness is found as the difference between the total and permanent hardness. So we can conclude that total hardness of this sample is 16 mg per liter and permanent hardness as 7 mg per liter and temporary hardness to be equal to 9 mg per liter. Total hardness can also be determined from the concentration of different metallic cations. Most often, the cations taken into account are calcium, magnesium, iron, aluminium, zinc, barium, strontium and manganese. The formula used is depending on hardness value, water may be described as soft, moderately hard, hard and very hard. Generally, hard water is considered suitable for human consumption. However, excessive hardness is objectionable due to many reasons. Hard water causes more consumption of soap to produce lather or foam. It adheres to the surface of tubs and sinks and may stain the dishes, clothes and other items. Excessive hardness may also make the skin to feel rough and discomfortable. Hard water can also modify color in the dyeing work. If water with excessive hardness is used in boilers,
ఆ, కాలేజీలకి ఓపెన్ చేయరంట. కాలేజీలు ఇంక ఓపెన్ చేయరమ్మా, ఆన్లైన్లోనే. ఇందాకే మైక్ తిరిగింది, ఈ జంగారెడ్డిగూడెంలో కరోనా కేసులు ఎక్కువగా ఉన్నాయంట. ఓపెన్ చేసిన తర్వాత చూద్దాం. మనకేమి ప్రస్తుతానికి ఏమి ఇవ్వాల ఇన్ఫర్మేషన్. ఏం ఓపెన్ చేస్తాం. చూసారా వీడియో అది, హార్డ్నెస్ ఆఫ్ వాటర్. బఫర్ ఒకటి వేయాలి. వైన్ చూసారు కదా. సింపుల్గానే ఈజీ. ఓకే అమ్మా, అటెండెన్స్ తీసుకున్నాను. అసైన్మెంట్ రాసారా ఈరోజు? అసైన్మెంట్ రాసారా పిల్లలు? మీకు ఇవ్వలేదా?